Good day, students. I am John Nathaniel, and so for today we'll be discussing about functions and relations. So let me ask you, do you have any idea what is a relation? When we talk about relation in mathematics, it is a rule that relates values from a set of values called a domain to a second set of values called a range. A relation defines the relationship between two different sets of information. If two sets are considered, the relation between them will be established if there is a connection between the elements of two or more non-empty sets. Next is function. A function is a relation where each element of the domain is only related to only one value in a range by some rule. Remember, it only has one input to only one output, unlike relation wherein it has one or more outputs. It is a binary relation between two sets that associate each element for the first set to exactly one element to the second set. Okay, next, function machine. A function machine is an imaginary device that receives inputs and generates outputs. A number or the input is put into the machine and is transformed into the second number or the output through the application of a rule. In this picture, this is the function machine, where you put the input here and the rule here, and the result will be the output. In the second picture is the example, where we put the input x equals 3 and the function is x squared. The output will be f of x is equal to 9. 3 squared is equal to 9, and that's correct. So we have different types of relation. Take note that one-to-one and many-to-one relations can be considered as functions, and all functions are relations, but not all relations are functions. First is one-to-one. Next are many-to-one, many-to-many, and one-to-many. So we have different ways of expressing functions and relations. Number 1. Set of ordered pairs. It is composed of two coordinates, the x-coordinate or the abscissa, and the y-coordinate or the ordinate. In a set of ordered pairs, the domain is a set of all coordinates while the range is a set of all y-coordinates. Take note, the set of ordered pairs can be considered a function if every element in the set is composed of different x and y coordinates, and no common x coordinates exist in the given set. So we have here examples. Determine if the given set of ordered pairs is a function or merely a relation. Identify the domain and range. Example number 1. We have 2 and 1, 4 and 2, 6 and 3, 8 and 4. Determine if it's a function or merely a relation. Look at its abscissa or x-coordinate in each pair, which are 2, 4, and 6 and 8. And if it's not repeating, then it is a function. And to find the domain, all you have to do is list down all the x-coordinates or the abscissa, which are 2, 4, 6, and 8. Make sure they're not repeating values. Like now, there's no double 2 or double 4. In the range, to get the range, all you have to do is write all down the y-coordinate or the ordinate, which are 1, 2, 3, and 4. And the same with the domain, do not repeat the values. Like now, there's no double 1 or double 2. Here are more examples. The next example is negative 1 and 2, negative 2 and 1, negative 3 and 0, negative 4 and negative 1. Since there's no repeating x-ordinate or abscissa, then it is a function. Then again, how to get the domain is negative 1, negative 2, negative 3, and negative 4, and that's your domain. The range are 2, 1, 0, and negative 1. The next example, we have 2 and negative 3, 3 and negative 2, 4 and negative 1, 5 and 0, 7 and 2. Since there's no repeating x-ordinate or abscissa again, then it is also a function. And to find the domain, these are the domain 2, 3, 4, 5, and 7. And to get the range are negative 3, negative 2, negative 1, 0, and 2. The next example, we have here 3 and negative 1, 3 and negative 2, 1 and negative 3, 0 and negative 4. As you can see here, the x-ordinate is repeating. There is double 3, 3 and 3, which makes this not a function. And the domains are 3, 1, and 0. This is what I said in the first example when you don't repeat the same value, which is 3 and 3. And the range are -1, -2, -3, and -4. The next example we have here 1 and 1, 2 and 5, 3 and 10, 4 and 17, 5 and 26. And it is also not a function because there is no repeating x-ordinate or abscissa. And the domains are 1, 2, 3, 4, and 5. And the range are 1, 5, 10, 17, and 26. So that's it for the first way of expressing functions and relations, which is the set of ordered pairs. So the second way of expressing functions and relations is the table of values. Tables of values is the set of ordered pairs that can be written as, of course, a table of value and is still composed of the x and y coordinates. The x coordinates are written on the first row and below are the y coordinates. So we have here examples. Transform the following given set of ordered pairs into a table of value. So for the first example, we have here 7 and 6, 14 and 12, 21 and 18, 28 and 24, and the answer will look like this. All the x coordinates will be in the top row, which are 7, 14, and 21 and 28, and all the y coordinates will be in the second row, in the y row, which are 6, 12, 18, and 24, and make sure they are in pair, which here 7 and 6, 14 and 12, 21 and 18, 28 and 24. In our next example, we have 4 and 3, 8 and 6, 12 and 9, 16 and 12, and the answer will look like this. It's the same method in the first example where we put all the x ordinate in the x row, which are 4, 8, 12, and 16, and all the y ordinate in the y row, which are 3, 6, 9, and 12. In our third example, we have 1 and 2, 2 and 4, 3 and 6, 4 and 8, 5 and 10, and the answer will look like this. In x, we have 1, 2, 3, 4, 5, and they correspond to the y coordinates, which are 2, 4, 6, and 8 and 10. In our next example, we have 2 and 5, 4 and 10, 6 and 15, 8 and 20, and the answer will look like this. In x, we have 2, 4, 6, 8. And under 2 we have 5, and under 4 we have 10, under 6 we have 15, under 8 we have 20, just the same in the ordered pairs. In our next example, we have 1 and 1, 1 and negative 1, 2 and 2, 2 and negative 2, 3 and 3, 3 and negative 3, 4 and 4, 4 and negative 4. If there are repeating values, it will look like this. In the x, we have the x ordinates, which are 1 and 2 and 3 and 4. And they should not be repeating. While in the y ordinate, we have plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4. It's basically combining both the signs of each the same number, which are 1 and negative 1, becomes plus and minus 1. Therefore, the answer will look like this. Always remember that a table of values is a function if there are no common coordinates in the row of the x coordinates. Now we have the third way of expressing functions and relations, which is through mapping. Functions can be written a mapping in which the values on the left side, which represent the x coordinate, will be matched with the values on the right side, which represent the y coordinates. We have here some examples. In our first example, we have 1 to 2, 2 to 4, 3 to 6, and there is only 1 to 1, then it's 1 to 1. And all 1 to 1 are functions, so this is a function. Our next example, we have 0 to 3, 1 to 6, 2 to 9, 3 to 12, and the same with the first example, it's 1 to 1. So this is also 1 to 1, then it's a function. In our next example, we have 1 to 2, 2 to 4, 2 to 8, 3 to 6, 3 to 10. So there's 1, then there's many, like 2 to 4, and 2 to 8, and it's 1 to many. And all 1 to many are not functions, so it's not a function. In our next example, we have 42, 43, 83, 12 to 4, 16 to 4, 16 to 5. And since there's many here to a single value, then many here to a single value, and it's many to many. Then all many to many are not functions, so it's not a function. In our last example, we have 2 to 3, 4 to 3, 6 to 7, 8 to 7. there's many here into 1, then it's many to 1, and all many to 1 are functions. Remember, only 1 to 1 and many to 1 can be considered as functions. Now we have the fourth way of expressing functions in relation by graphing it. Graph. The vertical line test can be used in order to determine if a graph is a function or merely a relation. Now, how are you going to use a vertical line test? Draw a vertical line passing through the graph in a rectangular coordinate place, just like that. Then determine the number of points of intersection between the graph and the vertical line, which you'll see in the example later on. Vertical line test. It is a graph that represents a function if it is possible to draw a vertical line that intersects the graph more than once. So in our example here, they are already recognized as functions. In our first example, we have a V shape or a U shape, which when we use the vertical line, and this is already a vertical line test, there's only one point of intersection, then it's a function. Even if we put it here or here, still one point of intersection, and it's a function. Our next example, we have a landing line, and our vertical line is here, and since there's only one point of intersection, then it's a function, even if you put it here in the middle or here. So in our next example, we have this type of line, and our vertical line is in here. Since there's only one point of intersection, one point of intersection, and it is a function. Even if you put it here or here, there's still one point of intersection. In our next set of examples, they are already determined as not functions. In our first example, we have a circle. Since if you draw a vertical line there, do a vertical line test there, then you have two intersecting points, which is here and here, which is make that not a function. Even if you put it here, it will not agree to all. Like in here, or the line here is still there. The vertical line test is, you can test in anywhere of the plane, just a vertical line. If it intersects 2 points, then it's not a function. Our next example, we have a C shape. Then our vertical line is in here. Since there's 2 intersecting points, then it is not a function. The fifth way of expressing functions in relation is through equation. Functions in relation can be expressed by means of any equation. We cannot consider an equation if there is no y in the equation. The exponent of y is an even number, y is an absolute value symbol, the relationship is not in equality form. Here are some examples. Which of the following equation are not a function? Given an answer. Our first example, we have y equals x squared plus 2. Then it is a function because it follows the rules. Our next example, we have x equals x squared minus 3, and it's not a function since there is no y. In our next example, we have x greater than y, and it's not a function because it's not in equality form. Our next example, we have y equals x absolute value, let me repeat myself. Y equals absolute value of x plus 3, then it is a function. Our last example, we have y squared equals x plus 2, then it is not a function because the exponent of y is even. See, y squared is not a function. Now for function notation. What is a function notation? A function notation are functions being written in different ways. Here are some examples. This is read as under function f, x maps to plus 3, or under f, x is assigned to x plus 3, or the image of x under f is x plus 3. And this is being read, in the next example, this is being read as the function of f is the set of all ordered pairs x and y such that y equals to x plus 3. In the next example, we have y equals x plus 3. It's like the basic one. In our next example, this is being read as f of x equals to x plus 3. In our last example, this is being read as the same as number 1, so x is assigned to x plus 3. Now, verbal examples. Write the function notation in 5 different ways satisfying the following condition. A function in which every element in the range is 9 less than the square of its corresponding element in the domain. The answer of number 1 is y equals x squared minus 9, and under f, x maps to x squared minus 9, and x maps to x squared minus 9, and the function of f is the set of all ordered pairs x and y such that y equals x squared minus 9, and f of x equals x squared minus 9, and that's the answer for number 1. And for next example, we have a function in which every element in the range is 25 more than 25 times its corresponding element in the domain. The answers are y equals 25x plus 25. And if you're wondering where I get the 25, it's that 25 times more its corresponding element. Then the plus 25 is from here. The range is 25 more than the 25 times its corresponding element, so 25x plus 25. So let me continue. Under f, x is assigned to 25x plus 25. Then x is assigned to 25x plus 25. The function f is the set of all ordered pairs x and y such that y is equal to 25x plus 25. F of x is equal to 25x plus 25. And our next example is a function in which every element in the range is 16 degrees by twice its corresponding element in the domain. And the answers are y equals 16 minus 2x. How I got this is from here. A function in which every element in the range is 16 degrees, so 16 minus by the twice its corresponding element, so twice 2x. 16 minus 2x. So under f, x is assigned to x16 minus 2x, and x is assigned to 16 minus 2x. And the function f is a set of all ordered pairs x and y such that y is equals to 16 minus 2x. Then f of x is equals to 16 minus 2x. In our next example, we have a function in which every element in the range is 27 less than the cube of its corresponding element in the domain. And the answer is y equals x cubed minus 27. How I got this is from here. The range is 27 less, so negative 27, than the cube of its corresponding elements, x cubed, not square. Then under f, x is assigned to x cubed minus 27. And then x is assigned to x cubed minus 27. And the function f is a set of all ordered pairs x and y such that y is equal to x cubed minus 27. F of x equals x cubed minus 27. In our last example, we have a function in which every element in the range is 125 more than the cube of its corresponding element in the domain. The answer is y equals x cubed plus 125. Where I got this is from here. The range is 125 more, so plus 125, and then the cube of its corresponding domain, so x cubed, not squared again. Then under f, x is assigned to x cubed plus 125. And x is assigned to x cubed plus 125. And the function f is a set of all ordered pairs x and y such that y is equal to x cubed plus 125. And this is being read as f of x is equals to x cubed plus 125. Take note. In order to write a statement into a functional notation, determine the first dependent variable. Then write the dependent variable on the left side and the independent variable on the right side. Now for a piecewise defined function. It is a function that is defined by two or more equations over a specified domain. The absolute value function given by f of x equals the absolute value of x can be written as a piecewise defined function as follows. Here we have some examples. Example number 1. You have a summer job that pays time and half for overtime. That is, if you work more than 40 hours per week, your hourly wage for extra hours is 1.5 times your normal hourly wage of 30 pesos. Write a piecewise function that gives you a weekly pay P of the number of hours H you work. So this is the weekly pay P, then this is the numbers of hours you work H, P of H. Now, and the piecewise function will look like this. Then 30 times your hourly work, that will be your payment. If H is greater than 0, or H is less than or equal to 40, then you get this amount of pay if you have H is greater than 40, which the equation below will become 1,200 plus 45 times the parenthesis of H minus 40. And I forgot to mention 30 is from the 30 pesos, and this 40 is from the 40 hours. 0 is basically 0 hours, and the 1,200 is from the 40 times 30 pesos. So that will result in the 1,200 if you work for more 40 hours. And the 45 is the 1.5 times the 30 pesos. So that's 45. The H is the number of hours you work. Then the 40 is here in the 1,200 already, so it's minus 40. In our next example, if you earn up to $113,700 in 2013 from an employer, your social security tax was 6.2% of your income. If you earn over $113,700, you pay a fixed amount of $7,049.40. Write a piecewise function to represent the social security tax of your income between $0 and $500,000. And use the f of x, and your piecewise function will look like this. How I got the 0.062 is from the 6.2%, just converted in a decimal. And x is your social security tax, your income, and x is this is only acceptable if your income is greater than 0 and less than or equal to $113,700. Then your tax will become $7,049.40 if your income is greater than $113,700 or less than $500,000. So in our next example, we have a museum charges $5 per person for a guided tour for a group of 1 to 9 people, or fixed $50 for a group of 10 or more people. Write a piecewise function relating to the number of people and to the cost C, so C of M. Piecewise function will look like this. 5n if the number of people is greater than 0 and less than 10. So this is the number of people, n, so 5. So that's a $5. So in our next function, which function 50 is $50 if n is greater or equal to 10. So that's immediately a $50. For our third example, your cell phone plan costs $75 per month and gives you unlimited talk and 500 text messages per month and no data plan. After 500 texts, it costs $0.10 per text you send. Write a piecewise function. Your piecewise function will look like this. You'll pay $75 if your messages just is greater than 0 equal to 0, or your messages are less than 500 or equal to 500. Then you'll pay 75 plus 0.10 parenthesis x minus 500 if your messages are greater than 500. 75 data per month, and 0.10 is the cost if you exceed 500 text messages. That will be multiplied to your exceeding messages. That's why it's negative 500. Another example is a motorcycle ride costs $20 for the first kilometer, and each additional per half kilometer adds $5 to the fare. Write a piecewise function, so f of d, and your piecewise function will look like this. $20 if your distance is less than or equal to 1, so So first kilometer, that's $20. If the distance is greater than 1 kilometer, then it will be $30 plus 5 parentheses d minus 1 over 0.5. Because if you exceed the first kilometer, the result here will be your payment. Okay, that's it for our discussion. Now, how was it? Any question and clarification? If you do, then please leave a comment in the comment box. Thank you for participating with me, and I hope you learned something from our discussion about functions and relations. Don't forget to like and subscribe, and also don't forget to hit the notification bell, and thank you. Relations.